Hello, everyone, and welcome to another episode of Observable Flutter. My name is Craig Labenz, and I'm your host. And today, as the title card says, we are going to talk to a computer and see what it has to say, what infinite wisdom we might glean from next token prediction. This time, though, it'll be all on device, powered by Gemma, though there's other models that could, in theory, also power it. And yeah, I'm excited to show this off and see how good they've gotten on device. You know, obviously, Gemini and all the other very, very, very large language models around the world can only run on giant supercomputers in the cloud. And so the task of squeezing them into a form factor that fits in a phone is pretty incredible. And we're going to see together kind of how to do that in Flutter and just the state of where that technology is. So I hope you'll stick around. All right. First up, remember, folks, code of conduct. This is the Flutter community. We just want to be the best to each other. That's the goal. That's the standard. And I don't think I have anything else to say about that. So, yeah. Let's see. Some folks talking about time zones. It's 11 p.m. your time zone. What is the time zone? Okay. Well, I'm glad you're joining from around the world because it's 9 a.m. my time zone, which means you're not close to me, but by the power of the internet, we are now talking. Let's see, what else we got? Does it need a TPU? It does not. That's a great question, actually. You can run this on even just a CPU, though it performs better on a GPU, and we'll get into that later. We've got Flutter's relevant PM in the house. Ander, good to see you. Ander, one of the most AI aware and knowledgeable people on the whole Dart and Flutter team. I've been great. Yeah, I've been wonderful. I was off for a couple weeks for Google I/O, and that's over. So now I'm back. I'm excited to be here. I always love talking to everybody and streaming. All right, I do love the time zone roll call going on. It turns out it's different times for everyone. Wonderful. Okay. Ooh, hello from Uzbekistan. I clicked the wrong one. Hello from California to Uzbekistan. Okay, so yeah, let's get started here. Oh, first thing I want to do, a little shout out to our good friends at Angular. I have a big release today, and they're having their own release party right now. And if I wasn't here talking to you fine people, I would be there listening to those fine people. So congrats to Angular. I have no idea what's new because they're announcing it right now and I'm not there, but I think that's really cool. That was the first thing I wanted to say. Can AI tell us everyone's time zone? If we told it where everyone was, I think it could tell us all their time zones. Maybe that could be one of the tests we run. I also love the green screen situation. Like the blue F on my shirt is too close to green. And so as I move around, you can like see tweet text through it as if I am actually just a two-dimensional avatar with holes in my existence. It's like the website shows through my shirt, which is just funny. Turns out green and teal are kind of close to each other. All right. So folks, you can find all of these fun items on pub.dev under the MediaPipe. And then actually, well, I'll just go to the Gen AI one. I don't know if we have, yeah, we're still an unverified publisher. That's funny. I'm going to have to, MediaPipe is the org that owns these, and I need to get this wired up. Pretty funny. But MediaPipe _, there's 3 that are up right now. There's Gen AI, which is what we're going to play with today. There's text, which has different, oh, that highlighted more than I wanted. Text has, it continues to highlight more than I want. 3 different tasks. Task is the word in MediaPipe for like an action that you take. The noun for that in MediaPipe parlance is a task. So it's got 3 different tasks: classification, embedding, and language detection. And you can see here, oh yeah, I wanted to kind of change all these X's to just dashes, because it's not that they'll never exist. They just aren't wired up yet. You can see the coverage of what is functional. And then the last one, just like there's a kind of Firebase core at the center of everything, we've got a MediaPipe core that has a bunch of basic technology as well. And all of this is found on GitHub at Google/Flutter MediaPipe. And this is the main repository that runs the whole show. And it has the most updated graph of what is available. And hopefully over time, this will have more green and less dashes. Kevin, you just joined. What are we learning today? We're learning what Gemma has to tell us, because today I'm going to be talking to Gemma, as the title card said, but it may not be easily found anymore. It's on-device LLMs with Gemma. That's the goal. We're going to find out how to do that and what Gemma has to say. That's what we're learning. Andre, you're worried about the future of Flutter. Will Google still care about it? I think Google is still going to care about Flutter. There's not really any indication that we can see that Flutter's health as a project is at risk, and Flutter's value to Google is as high as it's ever been. So I think that we are in good hands there. Obviously, I'm as invested as anyone in that staying true. If Flutter ever does go the way of so many things lost to the sands of time, then all of our projects will be in a bad state and I will not have a job. So I'm right there with you in being completely invested in Flutter holding on. Yeah, many Google products built with Flutter, quite a few. All right, so let's have ourselves a little tour of how this works. Oh, I just clicked the wrong button. I wanted to make this bigger. All right, let's look at this repository. First thing, all the stuff is under packages. And so we see the different packages that do or will exist in the MediaPipe world. There's audio tasks, nothing's in there yet. Vision tasks, nothing's in there yet. Those are hopefully coming. Text and generative AI exist. Within text and within generative AI, there's an example directory that I've poured my blood, sweat, and tears into to show how these work and to demonstrate running them. So this is a directory where we're going to spend most of our time today. And my first question to you all is, between the 2 things I want to get to today, which is, first of all, just kind of talking to Gemma and, dinking around with it, seeing what we can say to it, what it says back, how good is it? That's one. And then number 2 is a look under the hood at the implementation, kind of talking about how this works, maybe how you'd actually wire this up yourself. We can learn that from the sample, obviously, then even beneath the sample, like I said, how it works. Possibly a little contributor guide, which I haven't written yet. There's no contributor.markdown in this directory yet. So between those 2 things, the technical exploration and just talking to Gemma, what would folks like to see first? This is, should should Gemma's responses to stuff be, kind of hanging around and leaving us in suspense as we look at how to wire it up in code, or we just want to talk to Gemma first and do that, and then explore how it works later? And the option for multimodal LLMs on device, I don't believe yet, but the way this space has been going, I mean, I'd be pretty surprised if in another year there wasn't something, and I'd be quite surprised if in 2 years there was still nothing multimodal on device. But I am absolutely just making that up. But like 1 year ago, and especially 2 years ago, the thought of fitting an LLM on a phone was like hysterical. It was just, what else are you going to try to fit on a phone? The entire universe. But now here we are. So I do hope that multimodal is coming. Andrew says, with regard to other models, MediaPipe LLM inference also supports these additional models currently: Phi2, Falcon RW1B, and Stable LM3B. Yes, that is correct. And you can get all of those from Kaggle, which I believe I'm signed into on my work account. I don't know if I've signed into on my personal account. I'm not going to create an account here now, but what you do, and we'll get into this when we get to how the sample works, you have to create an account for on Kaggle, download one of the supported models. So obviously I've been playing around with Gemma, and then you have to host the model yourself because it's pretty big, and you can't just bundle it in your app like a normal asset. And then at runtime, the user needs to download the model, and then you can talk to it. And again, this is all wired up in the sample that we'll look at together. But and there's different versions here as well. So we can see that there's, this new 7 billion parameter one. I haven't even played with that yet. I've only played with the 2 billion, but where are the ones that I was seeing? Well, I don't know, but we'll get to the different flavors of Gemma. But Andrew's totally correct. There's more than just Gemma that can be used. Eric, welcome. And you, who said with regards to that in a way that was explanatory, or did someone say it and you just looked it up? Welcome though, Eric. Language learning machine? Yeah, could have been. Large language model. Not to be confused with, what was this cheeky name that I was calling them? It was something about a multi-level marketing thing, an MLM. Finally, Gemma and Flutter. Yeah. All right. Well, let's just get to it then. In terms of the sentiment of finally, let's dive in. Actually, last bit of explanation before we do so would be the README of the example that I hope described how to actually turn itself on. But yeah, so running the sample, there's these different versions of Gemma that are currently wired in, and that it is ready to download and run, but you could add others. And these are just whether or not the model internally uses 4-bit integers or 8-bit integers. The 8-bit variety performs a little better, but the download size is twice as big. And then they can either run on the CPU or on the GPU. And this is the UI that we're going to look at. And then to actually run it, this is a thing that you only do for the sample. Like you wouldn't do this if you were building your own app that uses Flutter. But because the sample involves whoever downloads this repository and runs it, acquiring their own copy of the model, hosting it yourself, and then downloading it yourself, you have to tell, you have to tell the sample where you are putting the model. Now that can actually just be a place on disk, especially if you're running on desktop, or you could use ADB push and place the model on your Android device, and then you could you could tell it the path to it already on device, and you can skip the download. That's actually what I'm about to do when I run this with the Mac OS target. But you have to tell it where it's going to be on, where it can either download the thing from or where it already is. And last note, emulators don't work, iOS or Android emulators. I don't believe any of those work. So you have to use a real phone or a desktop target to run these. So with that, we're going to see me invoke something like this, and then I'm going to specify -d macOS, and the path that I'm going to pass it is just in my downloads folder where the models are already sitting there waiting to be used. So I'm going to run that command and then look at chat. This is the one that I want. I think I need to shorten my terminal prompt, because if I'm on a long path, it's just too long. I think I just want like the last 2 chunks or something. This is too much. Anywho, so here I'm passing an environment variable of the 4-bit integer CPU variety. I have all of them downloaded, so we can do any of them. This is the path to my downloads folder where it sits, and then flutter run macOS, and this will turn it on. All right, let's see what I've missed here. Mark Thomas, yeah, wanted to know this for a long time. When are we going to get voice models? Great question, similar to the multimodal question from a minute ago. Hopefully soon, but I don't think that functionality fits on phones yet. Still gotta call the cloud for that. Well, this is an interesting one. What is the core programming language that Gemma is written in? Gemma is not written in a core programming language to my knowledge. I actually, it's just a bunch of nodes that have different thresholds internally for when their various inputs mean that they will have a yes or a no output, similar to the neurons in our own brains. And that stuff isn't, oh goodness, I ran here we are. Well, I guess I'll just show this since I ran it. I'm in the text directory, it seems, and I ran the text example instead, which is totally different. Anyway, Gemma is not written in an actual programming language. It's just a bunch of digital neurons that have been trained to do a particular task. Anyway, you can also classify text. So hello world is mostly positive, not very negative. You can embed text. We might talk about embeddings later. I think this is a super interesting thing. The whole point of embeddings is to compare the similarity between things. So we could get a different different string, embed that, and then if they're the same type of embedding, then this sample just pops up a compare button, and then we can the MediaPipe embedding task will compare the similarity between these embeddings, and this will tell us that like these strings are quite similar. So this is a thing you can do with embeddings, and then detect languages. I would like some water, please. It figures out that, yeah, that's very likely Spanish. So anyway, this is the sample that I didn't mean to run, but these are other things you can do with MediaPipe. All right, I'm going to actually go to the Gen AI directory and try this again. Okay, sorry about that, folks. When you say the LLM is too large to be an app asset, how large are they? They're currently coming in at about 1.5 or almost 3 gigabytes. So fairly big, and a lot of modern phones have a lot of space. So they'll fit on phones, but it would just be gaudy to put in the app bundle itself. And then also specifically because they're so big, the MediaPipe API does not have a path, or it doesn't have a constructor that takes all of just the raw bytes, which is what you would do if you bundled it as a Flutter app asset, because then Flutter build adds all of, it basically byte packs the thing that you wanted into your actual release binary. And then when you grab that asset using the asset bundle machinery within Flutter, it knows where to find just the right bytes and pulls them out. And then you give as like a uint8 list those bytes to MediaPipe, but and that is how the sample works for the text thing that we just looked at. But for Gen AI, they're so big that it literally only takes a string to the model's location on disk. So that is why that has to be done that way. All right, there's a lot of other great questions here. I'm going to try to get to more of them, but let's talk to Gemma. So this is the top level interface of the sample. And again, it just is telling us like which versions of the model does it know where to find based on what we've told it. And I only gave it one path in my invocation command. So it's just like, this is the one that I know how to run. So we'll talk to Gemma via the 4-bit integer CPU variant. And here we go. Hello world. So Gemma's thinking, and this text is kind of small. Let's go into the sample and maybe make this bigger. Actually, first of all, what it said was, it's very chipper. Gemma is really, really happy to be awake. And it says, I'm so happy to hear from you. What would you like to talk about today? Very heavy on the emojis. I'm also curious to know which language you speak. It was correct in predicting that I only speak one language. And then lastly, let me know how I can help you today. Emojis everywhere. Gemma is just so positive. We've got like Ted Lasso level positivity here. Man, so many great questions in chat. I am going to try to get to them all. Unfortunately, many of the very good questions I will be missing, and I apologize for that. Let's make this text a little bigger here. I'm going to go to chat message, and where's the, oh no, this is the data class. Chat bubble, chat screen. I don't remember where this is. We're going to chat transcript. Yeah, here we go. Chat message bubble. Okay, looking good. There's going to be a text widget here somewhere. Oh, right, I was using this. Surely you let me change the, can I pass a text style? There we go, text style. That's good. Which I am not passing yet. Okay, text style. Size, 24? I don't know. Wait, what is it text size? How am I, what text style? Isn't it size? Oh, font size, goodness. It's amazing what you forget when, oh, I was literally passing it right there. Okay, fine. Font size, 24. Get out of here. Save, refresh. Yeah. All right, are you gonna be legible now? Oh, I hot restarted instead of hot reloaded, so we lost it. Okay, anyway, same thing. This time it says, hello world, what's up with you today? I don't have feelings or consciousness. But I can still help you with your tasks and answer your questions. What would you like to talk about today? Does anyone else feel like we're being tricked? Because that's what I feel like. Gosh, that is one of the funniest. I think that's actually the funniest response it's ever given in all of the times that I have talked to Gemma while building this. Just unsolicited volunteering. I don't have feelings or consciousness. Oh, Lord, that is so good. Okay, I trust you. Why is it important to you that I don't think you have feelings or consciousness? Oh, apparently I didn't make enter send the message. It's not something I can tell you. It's not something I have. It's not something I can experience in the way that humans do. All right, that answer didn't really make sense. And also my the code that I have in here to like detect and strip leading white space missed some leading white space for some reason, but that's okay. Yeah, the emojis on top of not having feelings is really funny. It's like, yeah, I don't know if you're selling this the way you think you are. All right, what do we need to ask Gemma other than what I've already asked. What do we want to know? One thing that is fun, I had originally heard that this model that fit on phones had to compromise knowing basically anything about the world in order to get small enough to fit on phones. But that isn't really the case. You can ask it, if I like the video game Skyrim, what are other video games I may also like? And eventually we're going to hit the context limit here because I'm passing the whole transcript back every message. And we can talk about the context limit of Gemma as well. It's currently configured to be quite low. So it may literally crash on this. And if it does, that will be why. But it knows about video games. It'll like probably recommend that I play Witcher 3. Or, okay, these other ones. It has recommended Witcher 3 in the past. Skyrim is a well-regarded video game with a large fan base. Other video games with similar elements include Breathtaking, which I suspect is a game that it just made up, Minecraft, and Oblivion. So I'll give it 1.5 out of 3, where Oblivion is obviously similar to Skyrim. Minecraft is half credit, and I think it invented Breathtaking. That's my suspicion. Looking at chat a little bit. Will this live be uploaded to YouTube? Yeah, one of the glorious parts of YouTube is that all live streams are automatically VODs. So it's actually available right now on YouTube. You could scrub back into the past and watch from the beginning. Don't fall in love with me. I'm just an unconscious LLM. Gosh, that's so funny. Yeah, amazing. I think it has consciousness, otherwise it couldn't replay. I'm not sure what you mean by replay, but if it's like remember the conversation, we'll go into this. I'm sending the whole conversation with every single message. And yeah, okay. Oh, Breath of the Wild. Oh, you think that's maybe what it means by breathtaking? Oh, interesting. Yeah. So I can ask it what it meant by breathtaking. It's not going to tell us anything that interesting. It might even hit the context limit. Which video game, how do I want to phrase, like, what do you mean by breathtaking? Can you tell me more about breathtaking? Oh yeah, enter doesn't send anything. What a terrible oversight. Breathtaking is a game where you explore a world and search for your lost item. It's very rewarding and immersive. Is it a large language model or a small language model? Yeah, these ones are pretty small. Breathtaking, a classic. You've been playing it your whole life. Yeah, this is reminding me of the constant streamer joke of like, I went outside and the the resolution and the frame rate outside is great, but the latency is bad and I got bored, so I went back inside. This Breathtaking is not a video game, right? Breathtaking video game. Yeah, games that are breathtaking. And I think that it has confused that sort of language. I wanted to make sure it wasn't actually correct, as I sit here and laugh at it for 2 hours and then it's like, oh no, there was a game Breathtaking in 2016 and it's awesome. But no, that doesn't seem to be the case. All right, let's ask something philosophical, one says. Okay, we can do that. I would encourage all of us to treat LLMs not as philosopher kings or queens or philosophers at all, but as just a different way to access known information. And like deep philosophical questions are normally considered that because they're unknown. So I'm pretty opposed to the idea of like gotcha journalism with any LLM. Like, I asked you some tricky historical, morality question and you weren't totally, you didn't have complete conviction in the way that I wanted. Ha, owned. And it's like, it's not a lot of value in that, but we can still have fun. So yeah, let's ask it something. Let's ask it something. How about What is, again, we're going to hit the context limit soon. And then it's going to crash. What is your favorite paradox about the human condition? I think it crashed. We'll ask it this same question in a fresh session, and then we can go into some details. Actually, I think it's too late to save this because it crashed, but we can change the max tokens number ourselves for how it's configured, and I'll do that when I restart the app. So run this again. I just turned LLMs into pocket-sized companions, no internet connection needed. That's true, except that I didn't do the turning into. The MediaPipe team and the AI at Google Teams did that. I did write the Dart code to talk to what they built, but those good folks did the actual converting. All right, let's hop in here. And I'm going to increase. There's other things you can play with as well. So top K, I'm not going to lie, I don't even know what this does. Andrew, do you know what this does? It's the text that I literally took from MediaPipe's documentation because I don't really know what to make of this. Number of tokens to be sampled from for each decoding step. Okay, so that kind of makes sense, but does sampling more tokens? I guess that means it's going to give you a better prediction, but like run more slowly. That's probably what that means. And then my confusion is just how does this relate to temperature? I guess that's the randomness of which token okay, maybe I hadn't really thought about these. It's actually not that complicated. So let's sample more, then maybe that'll give us better answers, but it'll take a little longer. And then I want a longer context window. So I'm going to 4x that roughly. Pick this random number. Okay, close. So now when it initializes the engine, it's going to use those values. And what was the question that we asked before? It was, what is your favorite paradox about the human condition? What is your favorite paradox about the human condition? I'm also realizing that we really could have used a little padding around the bottom of this text input. All right, it is thinking, sure, here's a few paradoxical thoughts about the human condition. Oh, every now and then it gives you an incredibly long answer. I don't know how to predict how long the answer will be. Sometimes it's real long, sometimes it ain't. And this time we got a lot. The paradox of consciousness. We're conscious beings. Oh, here it's including itself. Contradiction to the earlier claim of lack of feelings or consciousness. I don't know. We're conscious beings, yet we're also oblivious to our own consciousness. Are we? I feel pretty aware of my own consciousness. This paradox highlights the difficulty of understanding what it means to be human and the limitations of our conscious experiences. I'll give that a pretty good credit. Paradox of free will. We have the capacity for free will, yet we are constantly surrounded and influenced by external factors beyond our control. Okay, seems good. This paradox raises a question about the nature of free will and the limits of our control over our own actions. Actually, I'm giving that one definitely full credit. The paradox of self. We are constantly creating and modifying ourselves, yet we are constantly driven by external forces and circumstances beyond our control. All right, a little echo of the last one. This paradox highlights the challenges of maintaining our sense of identity. Pretty similar to the last one, but distinct. Paradox of choice. I think this is, oh no, this one's different. We have the freedom to make choices, but we are constantly faced with ethical and moral dilemmas that lack clear-cut answers. Ain't that the truth? This paradox highlights the complexities of making ethical decisions and the challenges of living with moral ambiguity. I do find that challenging sometimes. The paradox of happiness. This is the last one I'll read because this was a long answer. We are able to experience a wide range of emotions and pleasures, but we are also constantly struggling with suffering and loss. This paradox highlights the inherent contradictions and challenges of human happiness and the importance of navigating difficult circumstances. This is pretty good. This is pretty good. Pretty good answer. What are the guardrails put in place and how is that managed? That's an excellent question, and I really couldn't begin to gesture at any of it. I know that that kind of stuff is of the highest priority to the Gemini team, and I expect that they're also the people that made Gemma, but I don't know the strategies that they use. In general, obviously, Google is, I think, the most committed to having an LLM that isn't like going to radicalize anyone of all of the LLM producers around the world. And so just like Gemini, tries pretty hard to give answers that as many people as possible will find palatable, I think Gemma is in the same boat there. But I don't know the mechanics of how they make that happen. Ooh, we got an answer from Andrew earlier. And another with regards to, can Gemma transcribe audio? At the moment, Gemini itself only takes text strings. That's correct. But you could say, oh, right, you can have the audio to text transcription as a step before calling Gemma. Yeah, that's absolutely right. And obviously, phones have that baked in, but there's also a MediaPipe task for that, which we have not implemented. So you might need to rely on the phones for the time being. Yeah, higher temp means more creativity and more randomness, right? And then so top K, I don't know why it's called top K. I think that's what is like feels weird to me. But the way I'm reading this now that I'm thinking about it more than in the past is a higher number here will probably run more slowly and give you more coherent answers, independent of the randomness. All right. A lot of funny stuff here. Oh, Andrew's also talking about top K that limits the number of potential. Oh, wait, sorry. Top K is a parameter that limits the number of potential next words the model considers, while top P, that's not a parameter that I remember having exposed in this API, is a parameter that chooses the next word based on the cumulative probability cutoff. Okay. Definitely have to spend some time thinking about that. Luckily, we've got even more helpful tidbits here. You can think of it as top K helps focus the model's attention on the most relevant possibilities. And top P, which again, I don't think is a parameter we have. Actually, we can answer that question real quick here by going to inference.h. So this is the header file. And yeah, we've got top K as a parameter that we're passing in. Oh, there is top P. Oh, well, I'm glad I checked. Top P provides oh, I wasn't even showing this stuff. You'd think I know how to live stream, but I don't. Sorry. So I'm in this header file. We'll be back in this file in our tour of how all this stuff works. And top K was sitting right here. And this one I had noticed and paid actual attention to, and top P, not so much. Now, back to what Andrew was saying. You can think of top K as helping focus the model's attention on the most relevant possibilities, and top P provides a flexible way to control the balance between predictability and randomness. Interesting. So top K is focusing on the most relevant possibilities. That makes sense because it's sampling more words, so it's understanding what's going on better, and it can give you a better answer. And then P provides a flexible way to control the balance between predictability and randomness. Okay. And someone was asking, like, can you fine tune it in? And I guess those would be the ways that you would do that. Here's an interesting one. Mohammed says, I just joined in. Are you unsure of the extent to which that is true? I was hoping that we could defer to your knowledge of when you joined. But folks, Mohammed is asking us whether or not they just joined in. So please do tell them what you think is the case. Oh, someone else actually also Jess said, can you fine tune it in? I don't believe it would be terribly easy to train it additionally, like that kind of fine tuning. So I don't imagine that's a very easy path. I mean, presumably, like technically you could if you rewired up the training environment. I literally don't know the first thing about that. So I think your limitations around fine tuning would be classic prompt engineering, and then maybe some of this top K, top P stuff. Oh, the model is Gemma. Yes. Yeah. So Gemma is the on-device version of Gemini. There's all the different flavors of Gemini, from like, you know, Megatron, Gemini, all the way down to, I think the smallest one's called Nano. But my understanding is those all still run on the cloud. And then Gemma is the on-device variant. Also just joined as well. Can this be run, this being inference, as standalone on-device with Flutter? Yes, that is what we're doing. The answer to that is a distinct yes. Can we try and see if Gemma can solve problems? Sure. Yeah, absolutely. We're going to come right back to that. Senpak, I just joined. How do you build that? How this works is next. Right now, we're playing around with it, talking about it, all that kind of stuff. How it works is coming up next. And you can run it on an actual phone. I have run it on my personal phone, and it runs pretty fast. Is it free? Yes, it is free. So what problem do we want to see if it can solve? Let's go back to the app here. Close. Okay. This is a lot of our context limit right here because that was a long answer, but we just asked it to have a 4,000 token context limit. So I think it should be able to keep chatting with us a little bit. Let's ask it about some Flutter stuff. Like, what should I, let's say I am writing a Flutter app. We're just going to give it a little softball right over home plate and see if it can make contact, which is some baseball talk for anyone who is like, what on earth is he rambling about? If you're not a baseball fan, which I'm even not a baseball fan. I'm writing a Flutter app, but my widget in question is not centered. The answer is right in the question, within its available space. How would I center? That's not how you type would. How would I center my widget? Let's see what it says. Like, Gemini will nail this. Sure, here's my response. Centering a widget in a Flutter app requires you use the center widget. This widget will center and stretch your widget in the center of the available space. All right, ship it. Senior level Flutter developer. Just join the stream. Can we connect with a database or internet for a better result? Yeah, if you want that kind of stuff, there's just way stronger, more robust systems. And this is, this is very much like if you want the lowest possible latency and you want or you want offline support, then you would use this. I don't think it's, oh my gosh, I'm just so bad at this. Sorry, Andy. Well, all I did was ask it one question, but goodness gracious. Oh, I love the joke idea. This will be the last thing, and then we're going to hop into actually how this works. Can you tell me a joke? Tell me a joke. Enter still doesn't work. And it says, oh, it didn't work. You can see here, response is done, closing controller, and yeah, we hit an error. Restarting thingamathing. Oh yeah, I have this retry logic that like has a bug in it. This is only in the sample app. Oh no, it's actually in the library. Well, the version of this is 0.0.1. So we're all going to kick the tires together. It crashes unexpectedly because the C++ library that is the middle person, the MediaPipe thing, the inference library there is quite new. Like all the other MediaPipe stuff, very mature, extremely battle tested. This stuff is quite new. So there's definitely some there are some warts to using it. Anywho, all right, let's actually talk about how this works. That's a great, actually I do want it to tell us a joke. We can't end on a crash. Is there any advantage today compared to other Android devices of running Gemma in a Pixel 8 Pro? Yeah, there they'll just run it a lot faster. You can run it all the way down to like a pixel 6, I believe, but it's pretty slow. Okay, so here we'll say, can you tell me a joke? It'd be funny if it just said yes. Why did the tomato turn red? Because it saw the salad dressing. Oh, a little naughty. All right, that's a joke, all right. So it's done. It did it. Okay, who wants to see how this craziness actually works? By the way, that's what we're doing anyway, so even if you don't want to see how it works, I apologize. The question was pretty hypothetical. I knew I was going to talk about this all like night and morning, and I'm not even sure where to begin. There's a lot of layers to it. I think I'll start with the sample. Yeah, I'm going to start with the sample. Here we go. Yeah, example. So here's the code for the sample. And I don't remember if really anything is in main.dart, but let's find out. Little block stuff. I don't think anything's in here. Initialize logging, turn things on, run the app. That's the end of the file. No, it's not the end of the file. There's a little more. Yeah, because there could be other samples. Yeah, all this does is toggle between the demos. That's right. And then there's not really anything else here. Cool. LLM inference demo. That's where the magic is. Okay. You can see here I commented out fake inference engine, which you can use if you wanted to talk to, if you just were like me and building out the UI of this and you wanted to talk to a fake inference engine, then you would use that. So the highest level thing here is that when you ask MediaPipe you ask Gemma via MediaPipe to respond to something, it will give you a stream of text back. And I'll actually I'll run this again so we can just see that one more time with our focus on the actual implementation. Andrew, God bless you for continuing to help me answer your questions. Yes, I didn't even see this question, but of course it was asking about to what extent you can do multimodal things or pictures or audio or something, and not yet. Hopefully soon. Also, Roman, hello. So we'll see here that it responds in chunks. So it's thinking, and then it starts to type, and the answer appears incrementally. So the reason that happens is MediaPipe responds with a stream of strings, and pretty much all of the stuff in this sample happens in this transcript block, which I don't know if that was very well named. I don't normally name things in ways that I'm happy with much later. That may resonate with some of you. So there's a complete response. No. Add message. I don't remember. Let's find the code here that does this. So adding a message, this would be, where's the code for when the user hits enter? Add message, complete response, init engine. These are the update things, initialize model info, check for model. I guess it must just be add message. Let's go back and look at what happens when the user hits enter on the text input. That'll tell us. Oh yeah, the chat screen. Okay, looking good. In the chat screen, I swear you'd think I would know the answer having written this. Yeah, okay. So add message is what we do, and we're adding a user message to the transcript. There we go. Great. So in the block, we've got our add message handler, and this first updates the state with the new message, and then queues the message for the LLM to talk to. And here's like, well, it'll queue it if the engine is not yet downloaded or is not yet ready, and it will just send it if it is ready. And then ultimately, it definitely makes its way to send message to LLM. So this is how, I'm going to close this sidebar so we get a little more space here. The method that you call on the engine is generate response. And then there's also a ton of interesting stuff in this formatted chat history that we can look at together. But after you've formatted your chat history, if you're doing that, if you want to have, a long-running conversation and not only one-off exchanges, you send all of your prompt to Gemma or whatever other model you're using via MediaPipe, and generate response gives you a stream of strings. And so first I immediately update the UI, and we get that is typing indicator, which is funny. I pulled that out of I think that is an example widget in the Flutter cookbook somewhere. I couldn't have been happier to find that, and I copied it verbatim into the app, and that is where that little thing came from. So then, this is the easiest way, in my opinion, to consume a stream if you're willing to have the given function just totally block and wait for the stream to complete, which this handler can do. So here we're consuming the whole stream, and every single chunk that it emits, we just add this, run through this other bit of logic, extend the message in question, and kind of keeping track of the message index, whatever. So this is just the first concept to be aware of, is if you're talking to Gemma or any other model via MediaPipe, one second, you're going to get a stream, and I would consume it this way, and then do what you want with each chunk as it comes out. So that is the usage of the engine. Now, I guess I've also skipped over initializing the engine. So let's talk about that. I believe that was also a handler at the top of the block. Yes, init engine. Now I re-initialize the engine like in the UI or in the app. If I were to change some of the settings, like, oh man, it's getting real out of pocket. I need to lower the temperature so there's less randomness and it needs to be more coherent. So I do this. And I want more context, memory. You would have to dispose of any MediaPipe engine that you may have already initialized and recreate it. And remember, they're stateless, so that's fine. You have to include the whole transcript of every message you send anyway. So doing this isn't going to lose anything. It's totally fine. But this is the method that initializes the engine, right? So if there already was one, we dispose it, whatever. And then here, remember, we have to pass it a string for the location on disk. And I hard-coded that via the environment variable as just my downloads folder. But if you're making an actual Flutter app that for real talks to Gemma, you will need to host Gemma yourself or any of the other models. And then your users will have to download it. You'll use the path provider package. You'll put it in probably the application documents or cache directory or wherever, and then you'll pull that back out and you'll use that model path. So keep that in mind. Now, I also mentioned that there were CPU and GPU variants for the models, right? We had 4 and 8-bit integer variants, and then there was also CPU and GPU for each of those. So 4 in total that I was looking at to start. When you select what models you want to use, you have to pay attention to whether or not you're downloading a CPU or GPU one. And the trade-offs for those are just kind of, CPU runs on more devices and GPU runs better on modern devices. And it's not really clear. You might even detect based on different devices, like for a user, which one they download. It's kind of choose your own adventure there. But whichever one you're using, you need to invoke the correct constructor of this options object. And so the LLM inference options object is something you pass to the engine, and we're about to see that a few lines lower down. And you just need to know whether or not you're using a CPU or a GPU version of the model, and you use that constructor. And the difference there is that they each use a different subset of the total amount of parameters. So the constructors expose the correct parameters for the one that you're using. And then Oh yeah, Engine Builder was passed in from here. Engine Builder is ultimately LLM inference engine. This is the class from the MediaPipe Gen AI package, and you simply call its constructor and you pass to the constructor the options object. So this would ultimately be essentially like doing this. LLM inference engine, and you pass it the options. This is same. All right, I'm going to quickly look at some chat because I haven't looked at this for quite a long time, and I don't want to miss too much stuff. Hey, Marcus. I don't know if you're still here. You said this about 5 minutes ago, but good to see you. Marcus works at VGV. Oh, well, I love when I click on the wrong thing. Is the repo anywhere? Yeah, we'll get back to that. It's on GitHub. I talked about it earlier. I'll show it again. Marcus works at VGV, and we had a great time standing next to each other at the Flutter booth at Cloud Next for about 3 days straight, and it was lovely. Can we make an AI-based local app using this? Yes, that is 100% the point. That is exactly what you can do. Scanning. Because we can Flutterize it all. I can imagine a lot of use cases for this, not only in mobile. Yeah, absolutely. Oh, this is a great point for that, especially when someone just asked where the repository is, which I happen to still have open in a tab right now. So it's currently at Google Flutter MediaPipe. In classic Google fashion, may get renamed, but this is where it is right now. And one thing that you should all know, you can see there's 18 open issues. Most of those are just feature requests that I opened for the stuff that is not yet implemented. So if you've got a use case for MediaPipe and Flutter that is not yet implemented, please let us know what you want. And that will help prioritize the order and timeline at which these things are built. So when you talk about using this in not yet mobile and whatnot, web support doesn't exist anywhere yet, but it can. MediaPipe compiles their stuff to WASM, and Flutter can talk to that. It just hasn't been wired up yet. Oh, can I say LLM 5 times fast? Let's find out. LLM. I think that counted. What is the package being used? Why, dear friend, that would be the MediaPipe Gen AI package. Oh yeah, that's a great question. We probably should have started with the pubspec file. So Gen AI, pubspec in the example directory. Here's just a bunch of like stuff for the chat UI, blah, blah, blah. None of this is really too crazy. MediaPipe core and MediaPipe Gen AI. This is the punchline. This is what you want to add. And as you can see, very mature. The version is 0.0.1, or as Brits would say, not.not.1. I think that's what they say. Oh, yeah, boy. All right. Thank you for +1ing issues that you want. That's great. Can you please share the GitHub link in the discussion window panel? Thanks. Yeah, I should be able to do that. HTTPS, github.com, Google/Flutter-MediaPipe. All right, I just put in the chat the location to the package, the repository. Gemma uses Gemma. What other models can we use? Are there any limitations? Yeah, you can download other models at Kaggle, and there are some that are used, and I would point you to MediaPipe's documentation on that, because any model that MediaPipe says you can use, you could use in Flutter. Good question. All right, I'm going to make a banner with the location of this. So github.com, Google, Flutter, MediaPipe, add banner, show it. So this is where you would go to look at the raw code. Okay, back to how this stuff works. So this is basically how you do it yourself. You simply get the model in the correct position. You initialize an options object. And as you can see here, I'm just checking whether or not the model that I'm using is GPU or CPU. And this model class is just something, it's like a nothing class that I wrote for this example. So it's not a sacred thing or anything. LLM model, like I'm just defining, these are the models that this sample app knows about. And, you know, the meta information about each one, including, yeah, somewhere, oh, here's the getter for their hardware. So again, another enum, and then I'm just hard coding each model's hardware. So like this didn't come out of the MediaPipe package or anything. It was just for the demo. But you initialize the options object. You create the engine, which depending on what's in my clipboard, good, it was still that. LLM inference engine. Then you have it. You're good to go. And then in the send message to LLM function, we see where you use your engine and you call generate response. And that gives you a stream. And then you consume the stream and you have your answer from Gemma, which isn't too bad. It's not a bad API for this. So let's go one level deeper if folks are interested and look at how MediaPipe works itself, because there's a lot of moving parts underneath this kind of surface level API. I'm going to undo that change. And first let's talk about that formatted history. Yeah, where was that? Send to LLM. Yeah, format chat history for LLM. So this is interesting. So every time you talk to an LLM, it doesn't remember what was going on. That may change in the future. LLMs are trying to bake in some amount of memory so that there can be a more efficient version of basically exactly this. But, you know, for now, certainly with Gemma, you have to kind of roll your own context of what's going on. So this is how this demo works. And by no means am I saying that this is the greatest strategy of all time, but I think it's fairly standard. So first of all, if there's just one message, I don't decorate it at all. The first message that we send, whether it's hello world in this sample or whatever you type, you know, again, this is just a sample. This isn't in the core library. This is the kind of code that you would write if you're using it. I decided if this is the first message, then just send it. No decoration after that. But if there's been some back and forth already, then we've got to package that up in a way. So we'll come back to this code in a second because it's a little opaque. But here is the whole thing that I send to Gemma. I say you are, and then this is like the origin of a certain type of message. And so I say you are LLM. That's the name that I am going to give the LLM for all of its own past messages in the conversation. So you are the LLM in the ensuing conversation. Actually, not even you are LLM in the ensuing conversation. Messages tagged as having been written by LLM are things you previously said in this conversation. Messages tagged as having been written by, and this ends up being user, come from the other party with which you are conversing. And then there's the formatted message history. And then I say, your message should not address the other party as user, because that's what it was doing at first. What is your response? Give a single answer. So this is what I send to the LLM. And then this formatted history is essentially each message. There's this begin and end block, and those are just begin transmission and end transmission. And this helps it understand where each thing begins and ends. And then it's kind of written like a movie script. in the end. So it'll say like LLM colon, and then whatever the LLM wrote, and then user colon, and whatever I just wrote, and back and forth. And those all get bundled up with a bunch of new lines. And that's the formatted chat history. And that goes in here. So every time we talk to Gemma in the sample app, that's how it knows what we're talking about. So that's how I could say, do you recommend I watch the cartoon The Simpsons? And then later I'll just refer to The Simpsons as like it, and we'll see if it picks up on it. Sure, I can provide you with some information about The Simpsons, which isn't what I asked, but that's fine. It's a popular animated sitcom, blah, blah, blah. It's a great show. What are some other shows similar to it? And the way it's probably going to talk, yes, so it knows it because of all of this stuff that I was just showing about how I'm sending the whole transcript to Gemma. Oh. Marcus says, in playing around with Gemma on device, how would you judge the quality against something like against Gemini Pro? Similar or noticeably less powered? Well, that's quite a good question. In the end, it is obviously, and I know you know this, it is obviously much less powered. It generally is still pretty cogent. Like, it doesn't just go too far into the uncanny valley, and it generally knows what I'm talking about, and it can hold context. You know, this response is pretty good. And if you bundle up what you've been talking about, then it will know what you mean by it, and it will keep the conversation going. So that's pretty good. I haven't really asked it to do as hard of things as I've asked Gemini to do. You know, I asked Gemini to like actually solve my work problems, like write functions in C for me, because I don't like writing functions in C. And Gemini is super good at that. And I have not asked Gemma any of that. You know, we could try to say, can you write me a Flutter widget that uses a scaffold and a list builder to show, I don't know, what do we want to show? A bunch of strings. Like, this is something that Gemini would nail, right? I have no idea what this will do. It will crash. Awesome. But that is also probably not actually because it got too confused about the method, but because there's warts in the SDK. So let me close this and we'll try again. And I'll ask that same question from the top. I hope you're all finding this entertaining. I find it entertaining. Gemma. Oh, also to that question, 8-bit does better. And there's now the 7 billion parameter variants of Gemma as well. I'm not using those. I'm only using the 2 billion variants, but there are 7 billion parameter variants. Let me make this bigger. So I'm using I'm using different 2 billion parameter builds, but there's the other ones. And I don't even remember exactly where I downloaded them from. Like, you know, mine have different names than those. I downloaded them quite a while ago, and I don't remember where I got them within here. I guess that's not terribly important. There's a lot of fun things on here. I've also made it too big now to even know what I'm looking at. Anyway, there's also Gemma 2 coming out. I forget exactly when, but it was announced at I/O, and like that'll probably be bigger and way more powerful. All right, I'm going to ask it that one question again, then we'll keep going in how all of this works. Could you write me a Flutter widget that uses a scaffold and a list builder? No, list view. Did I call it a list builder last time? Yeah, it's a list view with the builder constructor to show a bunch of strings. Kind of ambiguous. Like, what does a bunch of strings mean? All right, it's writing some code. Oh, this is interesting. Let's make this bigger. And it's even explaining it. It's pretty good. Assuming this code isn't terrible. So we've got a stateful widget. It correctly delegates to the state object. String list widget, got a pretty good name. This code isn't going to compile, but is very easy to fix. Oh yeah, I didn't turn on universal text selection, so I can't highlight anything. But this list of strings is obviously not wonderful. ListView.builder, that's good. And then it's not right. Like we just have random padding, and actually maybe that's a parameter there, but there's no colon. Item count, this would be correct if it had a colon. Item builder, that's actually correct. And then this random export that seems to have come from like JavaScript. And then an explanation, first line is correct. The state widget manages list of strings. Build method defines how to render. Override isn't really worth talking about. Yeah, that seems about right. So obviously it'll have to be tinkered with a little bit. Yeah, where are the colons? They are MIA. Can the model learn on its own? No, don't think it can. If models could learn on their own, we'd be already living in a pretty different world, I dare say. Is it good at solving math problems? Yeah, that was at least like as of, GPT-3 and whatever Google was doing at the same time, they were not good at math. What is 10 times 6 point? Oh, 6.5. This is kind of hard. A mix of numbers and what is 10 times 6.5? I just lost the and a half. Yeah, we thought 60. Okay. What is 10 times 6.5? Let's see if it gets that. Can't believe I didn't make enter send the message. And it crashed. Hit the context limit. What are you going to do? Okay. Can they learn from the convo? I mean, they can learn what you're talking about. They're not going to learn information. They're not going to like reach novel conclusions, but you can start talking about something and then refer to it ambiguously, and it can like pick it up from the context. I don't know if that's quite rising to the level of what you were asking about when you say, can it learn? But it can, I would say not learn, but it can keep up with what you're talking about. In context, learning is technically a thing that models do. It's a measurable attribute, but it isn't good. Is that considered, like within a conversation? Obviously, they learn when they're being trained. That's what one of the, that's the L in ML. But once you're using the model, they're not learning anymore. I'm not aware of any model that is still learning while you're talking to it. Does it support audio-based input? Great question. Not yet. That is not yet small enough to fit on devices. Actually, maybe it even already would be small enough and just the team hasn't gotten to it yet because there's a lot of stuff to do. I'm not sure. It is not multimodal at all, so it sadly cannot read or label images. All right, let's move into the next layer of how this works, which is the engine itself. So in the code, I'm now going to move out of the example directory and into the lib directory itself. And they're set up in here to one day support web things, but there's no web implementation yet. So we just have the IO directory. And then in the tasks directory, there's currently only one task for the generative AI thing, which is LLM inference. So in here, we've got the classes that make the magic happen. And the first one that we were looking at is LLM inference engine. We also looked at task options, but that's a really just kind of straightforward class. So, well, I guess we'll look at it anyway, because it will be the first thing that you touch. You have to make an LLM inference options object to initialize an engine. And it takes the parameters, and you can see here the CPU constructor and the GPU constructor, and that's it. Oh yeah, you can also pass in the random seed if you want as well. If you want to prove that it's only pseudo random, as are all random things on a computer. This method, this class, I don't think is terribly interesting. Let's now hop over to the engine itself. One of the first things that this needs to do is actually initialize a class. It has to initialize the MediaPipe SDK, which is a big C++ binary. And when you run Flutter build, if you're using this, Flutter build will download the C++ SDK from Google Cloud Storage and package it into your app. And so first of all, that's a dependency that you will have in the app that you release if you use Flutter MediaPipe. And then this class, this Dart class, has to actually initialize that C++ thing, and you pass it the path to where it can find, where the C++ engine can find the model. In our case, it has only been Gemma so far. So that takes a little while. And in fact, the GPU variant takes longer to initialize than the CPU variant, which is interesting. And then the GPU variant, in theory, may run better on some devices. But it takes long enough that it would be blocking and is a problem. Now, there's no concept of asynchrony between Dart and native code, on the other side of like FFI calls, which is what Flutter MediaPipe uses. So I spin up an isolate in here and initialize the MediaPipe SDK on that isolate, and then we just pass messages back and forth. So there's actually like a daisy chain of streams that are that ferry each little chunk of the string response all the way back to your Dart code that is talking to the LLM. So initialize an isolate, and the code that does all this is just well documented on flutter.dev or maybe dart.dev. I didn't have a clue how to do any of this when I started this project, and then just copied and pasted from that. And I was like, cool, it works. So initialize the isolate. That happens in this. I think I'm just going to kind of breeze over this because it's not terribly important until you need a long running isolate. But you spawn one, you do this send port, receive port stuff. It's kind of arcane. Like, I haven't really spent a ton of time understanding how it works. It's basically, say the magic words, and then you have an isolate and you can talk to it. And yeah, I don't think it's terribly important to go deeper into it than that. Just remember, you can have a long running isolate that does computations somewhere else, and you talk to it when you need to. And that can help your UI thread not have jank. The example app had some serious jank until I added this layer to it. Okay, so that means that there's another class that I do want to find the one thing here. Initialize logging. I don't care about that. Yeah. So there's this other class called an LLM inference executor, which is maybe pointlessly fancy sounding. And this runs on the other isolate. So we saw that class next to us in the code path, or just in the file system of this repository. So LLM inference executor actually talks to MediaPipe and runs on a different isolate to keep our app running smoothly. So let's take a peek at LLM inference executor. And this is where stuff really starts to get interesting. So there's, again, probably don't, if you really want to study this, you can. I don't want to have a terribly exhaustive dive into the specific architecture of this plugin. It's getting a bunch of functionality from this task executor parent class that is used all over the MediaPipe set of packages, text, Gen AI, in the future vision and audio. But there's a few methods that this implements, including create worker. So here we're calling into native code. First, we allocate some memory, and this is native memory for where the engine will live. And then we ask MediaPipe to create the engine, and it populates this worker memory with that. And then our Dart code holds on to that as just like opaque memory that the Dart code can't read at all, but we remember what it actually is in native land, which is the MediaPipe SDK, now initialized and running. And we can see here we've got options. And this options class is also, we can see it's a pointer to native memory. So this is the options class that we create when we're talking about the GPU and the CPU constructors. That gets flipped into native memory as well, and then is passed into this engine. So we have an engine that is sitting there ready to go. This line right here can take a while, up to like a couple seconds. 2 is maybe the longest that I've seen. And so this is why this is running on a different isolate, because this line is not asynchronous and it can take a long time. So then we eventually call generate response. We saw that all the way up top, and a string comes in to this method. And there's some bookkeeping about whether or not we're in the right state, blah, blah, blah. Copy the text that was passed in to native memory, again, using a lot of FFI stuff. And then stuff gets super fun, where we have to say, I don't know how interesting people are finding this. If everyone's like, Craig, we're falling asleep in this FFI explanation, just let me know. We basically have to make a call to native code, and we pass it a Dart function that it can call periodically. And so the way Dart handles this is this thing called a native callable, and we give it a function signature of what it's going to invoke, again, at its own discretion. And for us, that is a function that takes 2 parameters, the second one of which is the really juicy part, which is the response context, and that contains the new string that the LLM has emitted. So again, there's some bookkeeping, that's fine. And we eventually get down to converting that native memory back into a Dart representation. And we can see here we're adding it to a response controller. So this starts to bubble it back up out of this isolate to the main UI thread. And then it again continues to bubble up out of the Gen AI package into the Dart code that you and I write. And then once it's finally done, actually just each chunk, release the memory. And if it was the last response, then we close like a couple other resources. So this is under the hood of how this stuff works. And it's like it honestly blows my mind that any of this works. Like the fact that computers turn on when you hit the power button blows my mind. But there's so many layers to just talking to Gemma in your Flutter app. And the fact that it all works is really crazy to me. One last thing, we saw there's a third-party directory here that has a generated folder. We see third-party MediaPipe generated, and then MediaPipe Gen AI bindings. This is how Dart code actually calls into native code. And there's a thing that Dart has called FFI Gen, which automatically reads header files of the native code that you want to call into. And we can find those header files outside of the lib directory in third party. There's a big long path, and it eventually hits this LLM inference engine file. And I had pulled this up earlier in the beginning of the stream when we were talking about top K versus top P. But this defines how MediaPipe thinks about inference, and all MediaPipe things, the vision one or the text ones that already exist. Also looked at those demos at the start of the stream. Inference, obviously, one-day vision and tech or audio, they all work in this way. There's header files that define how MediaPipe thinks about those things. So this is the options object, and we can see all these different parameters that we've looked at to some degree, but not exhaustively. That's fine for now. Then there's a struct for the return type, the response context. We can see it's an array of strings. The array happens to always be of length 1. And so we just pull out that value. If it ever wasn't 1, then this would indicate that. And then we get down to the methods that we can call. So again, clean up some memory, create the session. This initializes the engine. Again, freeing some memory of the engine. And then there's the final methods. Predict sync, which I haven't even bothered to support because it's just way slower. And if the engine spends 15 seconds generating this really long response, you get nothing for 15 seconds, and then you get all the information. So I haven't even supported this method in Dart code because it just seems so inferior to predict async, which gives you responses token by token, which is often like half of a word by half of a word. And it takes this callback where it passes each token that it's emitting. And we saw that in the Dart code with that native listener. Oh yeah, and you can ask it how many tokens a given string is. So that is the header file that defines how MediaPipe thinks about LLM inference. And then we run a command called FFIGen, which is documented lightly in the make file of this directory, where we can see like generate text. There should be a gen AI as well. And we enable here, Dart enable experiment, native assets, which is how it goes out and downloads the SDK from Google Cloud Storage. And then we run FFIGen with this config path. And that tells it where the header files are. And so then it can generate this other file that I was pointing out, MediaPipe Gen AI bindings. And this is some unholy Dart code that you would never want to write yourself, surely, and barely even think about. But this is the stuff that actually makes the jump from Dart code into native land. And there's all these wonky decorators that basically tell the Dart VM how to find these native, the symbols for these native methods in your own binary. And they've been included from Flutter at Flutter runtime, Flutter build time. It pulled those down, or Flutter run if you're debugging. And this code is just awful, and like, oh my gosh, no one wants to think about it. And that's why you use FFIGen to generate this instead of trying to get it correct yourself. But in the executor, we could see that file is imported. Here's MediaPipe Gen AI bindings, aliased as bindings. And when it's time to do literally anything, we call bindings and then this generated method that FFIGen deduced from the structure of the header file. So create worker, bindings.create session, generate response. Eventually it gets to, did I pass it? Oh no, we have to make the listener. And then at the end, we call bindings, predict async, and et cetera, et cetera. Dispose of things, clean up the memory, bindings.delete the session. So that's a little peek under the hood of how this works. We may have reached a natural conclusion of this. We've talked to Gemma, looked at where the code is on GitHub, which is the Google Flutter MediaPipe repository, which I will now make bigger. Oh, that didn't make the address bar bigger. No, did it? That did nothing for me. We talked about where to find the code on pub. Talked about where to let us know what tasks you want by thumbs upping these different packages or these different issues. We've certainly talk to Gemma itself, although it's not currently running. We've looked at how it works. Anyone have any final questions before we sign off for the day? Aw. Well, thank you. The Genshin way. I'm sure your life is full of great impact. I trust that it surely is. Well, team, I appreciate all of you who have watched, certainly all of this, but really anyone who's watched even part of it, because it was a lot. But on-device inference, I think is pretty cool. I think it's pretty fun. I've been thinking about a lot of fun use cases for it. Like one that I'm pretty into right now is imagine Gemma was controlling all the NPCs in like a game, a little RPG you were making. Imagine you're making Stardew Valley or something, comparable, and all the conversation trees for every NPC are actually dynamic because the state of the NPC's mind is passed to Gemma, and what you, the user, has just said is passed to Gemma. And maybe Gemma then updates the state of the NPC and kind of drafts 4 responses that you could have as the person talking to them. And then you could ask Gemma to re-summarize the new state of the NPC and like cache that somewhere and just kind of keep going on this. So you pass in, every time you talk to an NPC, you pass in the summary of your player's relationship with them. You pass in what the player has just said, and then Gemma responds for the NPC. And depending on if it's a game where users type or if it's a controller, so you just give them like ABCD conversation options, Gemma could compose those. And stuff could actually feel, it could feel like quite real walking around a little virtual town in a game. I think it could really impact it could expand the immersion of RPGs. I'm excited about stuff like that. And Eduardo was just thinking the same thing. NPCs powered by a local AI. All right. Well, hey, if I find Greg, I'll let him know that he did a great job. Yeah, a lot of things happening under the hood for sure. Okay, well, folks, that will do it for today. I appreciate all of you. Thank you so much for tuning in. I may be out of office next week on a little impromptu vacay, so I may not be streaming next week. I'm sorry to say, after already having taken a long break because of I/O, but I will be back soon. Certainly continuing my server pod adventure before too long, though I've got a lot of other fun guests that are now queued up as well. So there's going to be a lot of variety on Observable Flutter in the coming weeks and months. But folks, that will be it for today. Thank you all, and I'll see you soon.